Hey guys, this is question MM084 from the Maths Methods Sharpened Study Guide. Part of the graph of the function h of x equals 4 take 2e to the power of 1 take x over 2, where the domain is all real numbers, is shown on the axes below. This is obviously the graph. Find the rule and domain of h inverse, the inverse function of h. So, let's start by rewriting out the original equation. We've got h of x equals 4 take 2e, 1 take x over 2. Awesome. And then you need to write 4 inverse, swap x and y. Which means that we get x equals 4 take 2e to the power of 1 take y over 2. And then we just rearrange for y. So we basically need to get y by itself, and then that'll be equal to our inverse. So yep, we just take 4 from both sides. We get x take 4 equals negative 2e, 1 take y on 2. Divide both sides by negative 2. The negative makes this 4 take x, and then over 2, which equals e to the power of 1 take y over 2, which means that log e of 4 take x over 2 is equal to 1 take y over 2. Which means that 1 take y is equal to 2 log e of 4 take x over 2, and then adding y to this side and taking the log from that side, we get y equals 1 minus 2 log e of 4 take x over 2, which means that the inverse of h is equal to 1 take 2 log e of 4 take x over 2. And so this is our rule. That's awesome. But we also need to find the domain. So there's 2 ways to do this. One, you could just find the domain of this log here, which I feel, well, they're just as simple as each other. So finding the domain of this, or if you find the range of the original, that'll be the domain of the inverse. And I always like to do that just to make sure that I'm doing it correctly, essentially. So the range of h of x is equal to negative infinity to 4, because this is going down to negative infinity, and this asymptote here is 4, because this 4 is here. Which means that the domain of the inverse of h is equal to negative infinity to 4. So our domain is this, and our rule is this, and that's 1 mark, that's 2 marks. The total is 3. So essentially our first mark is, well, yeah, so our first mark is here, swapping x and y. Second mark is this one, third mark is this. And that's your final answer. II. On the set of axes above, sketch the graph of the inverse of h. Label the axis intercepts with their exact values. So firstly, we want to actually find what those axis intercepts are. So we know that our regular equation is equal to 1 take 2 log e of 4 take x on 2. And we want to find the y and x intercepts. So y-intercept occurs when x equals 0, which means that this equals 1 take 2 log e of 4 on 2, which equals 1 take 2 log e of 2, which is our exact answer, exact values. So our y-intercept is 0, 1 take 2 log e of 2. And then we just need to find our x value, which is when, our x-intercept, which is when y equals 0. So 0 equals 1 take 2 log e of 4 take x over 2, which means we take 1 from this side and divide by negative 2, which means we get 1/2 equals log e of 4 take x over 2, which means e to the power of 1/2 is equal to 4 take x over 2, which means that 2e to the power of 1/2 is equal to 4 take x, which means x is equal to 4 take 2e to the power of 1/2, making our x-intercept 4 take 2e to the power of 1/2, 0. So then what we need to do is actually sketch the graph. So let's go back to the axis. And because this is a log and it's the inverse of this graph here, we know that there's an asymptote at x equals positive 4 because there's an asymptote on the original of y equals positive 4. Awesome. And so our y-intercept is 1 minus 2 log e of 2, which is going to be about here. And our x-intercept is 4 minus 2e to the power of a half, which is about here. And the reason I know that they are there is because of how the inverse is shaped. Remember, it gets reflected over the y equals x line, which means that it's going to sort of flip, and it's going to look something like this. Then all we need to do is just label these points. So there's not really much room here, but I'll probably just do this. Equals 0, 1 minus 2 log e of 2. And this one here is equal to 4 minus 2e to the power of a half, 0. And that's our inverse function, and you'd probably label that there. And that's it, that's your final answer. Part A, I. Find the coordinates of any points of intersection between y equals the inverse of h and y equals h. So whenever you're finding the points of intersection between two graphs, all you need to do is let them equal each other. So we know that the inverse of h is equal to, well, actually let's write it out. So we've got the inverse of h equals h of x, which means that 1 take 2 log e of 4 take x over 2 is equal to 4 minus 2e 1 take x over 2. Now, this is one for your calculator. Don't try and solve this by hand. You most likely won't be able to because it's very difficult. I'm not actually sure how you would solve something like this by hand, so use your calculator. According to Kaz, you get x equals negative 0.715 and x equals 3.397. Now, since the inverse of h is inverse of h of x, the points of intersection always occur on the y equals x line because they're reflected over that line, which means that at the points of intersection of an original graph and its inverse, the x value and the y value are the same. So the points of intersection are negative 0.715, negative 0.715, and 3.397, 3.397. And that's your final answer. All right, calculate the area enclosed by the graphs of h and the inverse of h. Give your answer correct to 2 decimal places. Cool, so if you haven't done the anti-differentiation section of your course yet, don't worry about this question, just skip it and come back to it later. But otherwise, this is testing the the area between two graphs. So we've got a graph h of x and inverse h of x. And we know because of the graph that that h of x sits above the inverse of h, which means that in this formula we're going to have the antiderivative or the integral from a to b of h of x dx minus the integral from a to b inverse h of x dx. So whichever graph lies above the other one, that comes first in this equation. So the area is equal to this. Our first x value of the point of intersection is negative 0.715. And our second is 3.397, as we figured out before, where h of x is equal to 4 take 2e to the 1 take x on 2 dx. And these are the same values. And the inverse of h is 1 take 2 log e of 4 take x on 2 dx. Awesome. Now, according to our calculator, so Kaz, the area is equal to 5.42 units squared. We don't have any units, so you just got to write units, and it's only 2 marks. So the first mark is here, and the second mark is actually getting the answer. Don't do this by hand. It will take extremely long, and you might not be able to do it. So 5.42 units squared is your final answer. Part B. The diagram below shows part of the graph of the function with rule f of x equals a plus b e to the power of negative k times x plus 1, where a, b, and k are real constants. So there's a few things here. The graph has a horizontal asymptote with equation y equals 2. So this is y equals 2. The graph has an x-intercept at -1. That's -1. And the point z on the graph has coordinate z -5, where z is another real number, which is somewhere here. Awesome. State the value of a. So a is always our asymptote in exponential equations and graphs, which means that our a value is equal to 2. A equals 2. That's as simple as that. It's only 1 mark, so simply stating that is enough. Part I, find the value of b. So we have f of x equals a plus b e negative k x plus 1. And we know that a is equal to 2. So we have 2 plus b e negative k x plus 1. And we know that we need to find out what b is. So how do we do that? We know that there is an x-intercept at x equals -1. So that means that the y value is 0. So 0 equals 2 plus b e negative k -1 plus 1, because x is -1 at that point. -1 plus 1 is 0. Negative k times 0 is 0. E to the power of 0 is 1, which means that we have 2 plus b, 0, which means that b is equal to -2. And that's our final answer. Question BIII. Show that k is equal to log e of 2 on 7 over z plus 1. So, you may not know where to start with this question, but let's just start by rewriting the equation and then we can work from there. So we've got f of x equals 2 take 2e to the power of negative k x plus 1. And we need to figure out what k is, and it's actually in terms of z. So what we need to do is use that coordinate that has z -5. So we know that there's a coordinate at z -5 because the question tells us. And we know that we need to use this because there's a z in the answer here, but there's no z otherwise in this equation. So let's go ahead and sub these in. So we know that f of z is equal to -5, which means -5 is equal to 2 take 2e negative k z plus 1. Awesome. And then we just rearrange for k, because we know that k is going to be by itself on this side, which means that we need to just solve for it. So we take 2 from both sides, which gives -7, and then we divide that by -2, which gives us 7 on 2. Awesome. From here we can rearrange this into a log. So log e of 7 on 2 equals -k z plus 1. Which means that -k is equal to log e of 7 on 2 over z plus 1, which means that k is equal to negative log e of 7 on 2 over z plus 1. Now, this looks very, very similar to our final answer, but it's not quite there. And don't freak out if you got this, because this is actually correct. What we need to do is just take this negative, and whenever there's a number out the front, because there's actually a -1 out the front here, we can take that and do 7 over 2 to the power of -1 over z plus 1. And anything to the power of -1 is 1 over that number, which means that a fraction just flips, which makes it 2 on 7 equals z plus 1. And I like to write as required, or as rec, because it's a show that question. It's not necessary, but I personally do that. Awesome, so that's our final answer. K equals log e of 2 on 7 over z plus 1. Part BIV. Show that the gradient of the tangent to the graph of f at the point z is 7 log e of 2 on 7 over z plus 1. Alright, awesome. So, whenever we see gradient, we are talking about the derivative So if you haven't done the differentiation component of the course yet, don't worry about this question, skip it and wait till later. So we know that f of x is equal to 2 minus 2e, and we now know what k is because of our previous question. So what we do is we actually sub that in for k. So we know that there's a negative k up here, which means we get negative log e of 217 over z plus 1 times x plus 1. And that's actually our function at the moment. So again, according to Kaz, this is a ridiculous question, so don't try and do this by hand. The derivative of x is equal to, bear with me, I've got my notes here. We've got negative log e of 7 on 2 times 2e to the power of negative x take z over z plus 1 times 7 to the power of x plus 1 over z plus 1, and then that all over z plus 1. So this is the reason why I said don't do this by hand. And then we know that the point that we're looking for is z, and we know that the x value of that point is z, like little z. So then we want to get f dash of z, and if we put this into our calculator, this actually gives us negative 7 log e of 7 on 2 over z plus 1, which looks almost identical to this suggestion up here, or not suggestion, the answer up here, except for that negative, and again, we simply take the negative 1 to the top of this power, which flips that around, giving us 7 log e of 2 on 7 over z plus 1. So the first mark is actually getting this derivative, and then the second mark is applying the z into it and finding this answer. And the reason why that simplifies it so much is because when you replace these x's with z's, it actually makes the whole equation a lot smoother and simpler. So this is your final answer. All right, part BV. If the tangent referred to in part B IV passes through the origin, find the exact value of z. Awesome. So we're still talking about this tangent, which means that we know the gradient is equal to 7 log e of 2 on 7 over z plus 1. So that looks like a z. That's a 2 there on top. And we also know that it passes through the point z negative 5 and 0, 0. Which means that this gradient is the same as the rise over run between these 2 points. So we know that 7 log e of 2 on 7 over z plus 1 equals rise over run, because gradient is rise over run. Now, rise over run between these 2 points is y2 minus y1 over x2 minus x1, which gives us negative 5 take 0 over z take 0, which means negative 5 on z equals 7 log e of 2 on 7 over z plus 1. We multiply both sides by z plus 1, which gives us negative 5 times z plus 1. And this z we can times to the other side. So we get 7z log e of 2 on 7 equals negative 5 times z plus 1. Awesome. And then what happens is we get 7z log e of 2 on 7 equals negative 5z take 5. And then what we want to do is we want to get the z's on the same side. So we add 5z here. So we got 7z log e of 2 on 7 plus 5z equals negative 5. And then what we want to do is actually take out the common factor of z, or z. And you know that you need to do that because you actually are trying to find what z equals. So find the exact value of z, and that means that we need to get it by itself. So z outside of 7 log e of 2 on 7 plus 5 equals negative 5, which means that z is equal to negative 5 over 7 log e of 2 on 7 plus 5. Now, this is an exact value, and we are after an exact value, so that's good. You can do this on your calculator, but just be careful about the exact values and the numbers that you're putting in. So this is the method. Just use your rise over run between the 2 points, and you know what the gradient is. So Z is this, and that's our final answer.